Flying in a 747 from one side of the Earth to the exact opposite side would take about 22 hours. Now, I know there's a bit of rock in the way, but that's really going the long way round.
So what if we did dig a hole all the way through the Earth, through the center, and jumped in?
Well, Michael, you probably wouldn't make it very far. That's because of the Coriolis effect, which is why a ball curves weirdly when you toss it while riding a merry-go-round, and why hurricanes always spin counterclockwise in the northern hemisphere. At the equator, the Earth, and you on it, is rotating eastwards at 1600 kilometers per hour. As you go deeper, the bits of Earth around you are still spinning around once per day, but they don't have as far to travel, so they're going at slower and slower speeds. If you jumped into a vertical shaft, you'd soon be traveling east faster than the rock around you, so that after falling only a few kilometers, you'd crash into the eastern wall. It might not be a disaster, but some miners near Lake Superior tried to test this by dropping cannonballs down a mile-long shaft, and the balls never reached the bottom.
Okay, so what if the tunnel went from pole to pole so the Coriolis effect didn't apply? And let's also assume that there's no air resistance or friction.
Okay, since the Earth's mass is more concentrated close to the middle, gravity would actually pull you down with about the same amount of force for the first 3,000 kilometers. This familiar constant force would accelerate you until you were falling 8 kilometers every second, and the trip halfway to the middle of the Earth would only take 13 minutes. Soon after, you'd reach the Earth's outer core, and this is the point in your journey where the pull of gravity would be strongest, but only slightly stronger than the force we're used to on the surface. As you continued to fall closer to the center, so much of the Earth's mass would now be above you that it would begin to seriously cancel out the attraction of the mass below, and the downward pull would weaken until you reach the center. Here, you'd experience no gravitational pull at all. Or rather, the Earth would be pulling on you the same amount in all directions, so you could float freely around with no sense of up or down. Except remember that you'd be speeding past at 22,000 miles per hour, or 6 miles a second. Once you pass the center, the whole process would reverse and you'd gradually slow, pulled down, or is it up? Weakly at first, and then more strongly, until when you got to the other side, you'd stop moving and could step out on the surface, a mere 37 minutes or one dryer cycle later.
Of course, the deepest we've ever been able to dig is the Kola Super Deep Borehole in Russia, but it only went down 12 kilometers, which is only 2/3 the length of Manhattan. They had to stop because it got too hot, 180 degrees Celsius, and this is sort of the problem with digging a hole through Earth. Earth is hot and molten in the middle. You can't just dig a hole through it with shovels. But here's a question. What if the middle of Earth wasn't all liquidy? What if Earth was hollow, but weighed the same?
Well, with its entire mass concentrated in the thin shell right under our feet, the Earth wouldn't have a magnetic field anymore, because that comes from the molten iron core. So we'd be totally vulnerable to radiation from the solar wind and solar storms, and this means we'd see the aurora everywhere. Look, the northern, eastern, southern lights! And if you jumped inside the hollow Earth to escape the solar storm, well, gravity from the different parts of the spherical Earth shell would perfectly cancel out, and you'd float freely about inside as if the Earth weren't there at all. Of course, you'd better bring a spacesuit because there's not nearly enough air on Earth to fill up the entire inside of Earth. But what if the entire inside of the hollow Earth were covered with mirrors?
Henry, that's ridiculous. For now.
Okay, so back outside of the Earth, we wouldn't really notice much difference, at least not from a gravitational perspective. Falling things would still accelerate at 9.8 meters per second squared, a baseball would follow the same trajectory,
and the moon would follow the same orbit around the Earth.
Hey, Henry, let's go to outer space right now. Bring your gun. This will all make sense later. Come on. Oh, and you're coming too. Click this annotation to go over to my channel, Vsauce, to see the rest of our adventures. I'll see you over there.